So we're going to find the values of the 6 trig functions to 4 decimal places, given the ordered pair 7, 23. Now, one thing about these instructions that I want to point out to you is that they're telling you 4 decimal places. In order to get that, first you have to find the value of the trig functions exactly, and then you put them into your calculator to find the value to the 4 decimal places. Your calculator will probably take it beyond 4 decimal places, and then that means you will need to round appropriately. So always read the directions of the problems before you start working the problems, because they tell you exactly what we're looking for here. Now, to work the problem, the first thing we notice is that x is 7 and y is 23. And the first step that we find is r. So we write down the formula. Get into the practice of always writing down the formula you're going to use before you use it. Not only does it help cement that formula into your head, it also helps you get a feel for the problems that you are using the formula for. And so we write it down, and of course, plus you're showing your professor or anyone reading your work that you know which formula to use. This is part of showing your work, and I know that you're going to have a calculator, and I know that you're just going to want to plug the numbers into your calculator and just say R equals something or other, but I really don't want you to do that. This is important that you show me where all the numbers are coming from. No pulling rabbits out of hats. So I write down my formula, R equals the square root of x squared plus y squared, and then I show how I plug it in. 7 squared plus 23 squared. This part you put into your calculator, and what you get out of it is the square root of 578. Notice that I did the square root and I showed what went underneath the radical before I did any other sort of calculation on this, because this is the exact value. And maybe the number underneath there would reduce to a more comfortable square root value, you know, like you've seen. It could be a perfect square, it could be all sorts of things. But at least do this and show me the exact value. And then you want to show me what the approximation is. And I'm going to take this one just to 2 decimal places. We'll talk more about that in a later class, but at least I have this. Now the next thing I want to do is write the ratios for the 6 trig functions. So again, write the formula, write the formula that you're using, and then write in the values that you're using. 23 over the square root of 578. Show me, because what you're doing here is you're finding the exact value. And then, because the problem asked for the values of the trig functions to 4 decimal places, then you can put in your numbers and you get 0.9567, and that's rounding appropriately to 4 decimal places. Remember, rounding, if to the 4th decimal place, we look at the 5th, and if it's 0 through 4, you just truncate, and if it's 5 through 9, you bump. If this digit is 5 through 9, then you bump up the place that you're rounding to up by 1. So this is approximate, and this is exact. And in all honesty, you really didn't even need to do that. Sometimes you need to write it down, but always write the exact first. And then show me the exact in your ratio. And then if the problem is asking for a decimal value, then show me the approximation. And this is absolutely crucial. I get students who figure that the answer can't be right until they write down decimal numbers. And I will tell you as a mathematician that this is exact, it's right. This is not exact. And we use approximations when we have to, but it's always better to give the exact first. Once you understand this, then the rest is just going through the pattern. Cosine equals x over r. So it's 7 over the square root of 578. And then you put it into your calculator, and what you get is 0.2912. So you see what we're doing here. The pattern is find the exact first and then show me what the decimal is. If you skip these steps on a test, I will take off points because you're not telling me where that number comes from. I don't assume just because you put the right number down that you got it right, that you knew where it came from. You have to show me the work. So we've done those two. We have 4 more to go, and I'm running out of space on my whiteboard, so I will erase and keep going. Then we say tangent of theta is equal to y over x. So that's 23 over 7 is the exact, and then 3.2857 is the approximation. Cotangent of theta is x over y, 7 over 23, and that is 0.3043. And notice I'm putting in theta as my angle. You never just write tan or cot or cos. You always have to have some sort of angle name with it. These are functions, just like squares and square roots and other things that you learned about in your algebra class. If you have a function, you have to have an input variable, and that's what this theta is doing, is playing the part of the input variable. So then you show your ratio, you show the numbers you're putting in for the exact value, and you show the approximation. We have 2 more functions to do. So we say secant of theta is equal to r over x, which is the square root of 578 over 7, and that is 3.4343. And then we have cosecant of theta, which is r over y, and that is the square root of 578 over 23, which is 1.0452. And again, if your numbers here are not matching mine exactly, but you're showing me these steps, you'll get the points. Unless they're really far off because you didn't do this calculation right. But let's say you rounded it to 3.4342. I am more likely going to give you full credit for that than I would if you just wrote down 34342 and you didn't show me where the number came from. So give me something to work with on your tests. Show me your work. So I cleared my board and I set up the second example, and this time the instructions say find the exact values of the 6 trig functions. And then they gave us this point, -3, 5, where this is x and this is y. So here, with the exact values, you really aren't going to give me a decimal response at all. You're going to keep everything in exact. So we have x and y. The first thing we find is r, which is the square root of -3 squared. Note the notation, put parentheses around the -3, so the square squares the whole thing, plus 5 squared. And I should write the formula, so I'm going to write it up there. X squared plus y squared. Okay, so I have my square root of minus 3 squared plus 5 squared, which is the square root of 34. And that's exact. If it helps you to write down 9 and 25, and then that's 34, that's fine. You can show intermediate steps, but you at least need to show me these steps. Now, the book points out, and I point out, and I totally agree with the book, that when you're doing exact answers, it's acceptable to leave radicals in the denominator. I'm sure you've been trained all your mathematical life, never leave a radical in a denominator. That's great, that's a good habit to have, but it's not required for this class. And quite often it's not going to be required for other classes that are higher level than this. So it's okay, you have permission to not rationalize the denominator. All right, so I have sine of theta equals y over r equals 5 over the square root of 34. We have cosine of theta equals x over r equals negative 3 over the square root of 34. We have tangent of theta equals y over x equals 5 over minus 3, or if you're comfortable with that, minus 5/3. Then there's cotangent of theta equals x over y, which is negative 3 over 5. There's secant of theta, which is r over x, and that is the square root of 34 over negative 3. And there's cosecant of theta, which is r over y, and that's the square root of 34 over 5. And that's all you have to show for this problem. The only calculator work I might have needed was to figure out what this square was, the sum of the squares. So honestly, finding exact values is a lot easier. Some people just get so worked up into their calculator that that's all they can think of, is that's what they need to do, is always show that their calculations went through a calculator. And I'm not that way. Mathematicians are not always that way. We prefer exact answers in many, many cases. So when in doubt, do exact first, and then if the instructions ask for a decimal, go ahead and put in the decimal.